Okay, good morning. We're going to cover section 7-2, which is properties of parallelograms. So if you could look at page 202 in your student journals, that would be terrific. I'm going to give you a few minutes to get those out. Okay, well, a parallelogram is a quadrilateral with both pairs of opposite sides being parallel. So it's really in the name. It says parallel in the name. So a parallelogram is a four-sided figure. That's a quadrilateral. And opposite sides are parallel. So here is a quadrilateral. The name of this parallelogram is ABCD, and for this to be a parallelogram we would need opposite sides to be parallel. So let's discuss what the opposite sides are. So the opposite sides are AB. So here is side AB. And what side do you think is opposite of AB? And sure, that's pretty self-explanatory. You would assume that that is DC. So if those sides are parallel, then we would put an arrow here to indicate that these two sides are parallel to one another. So we know that AB is parallel to DC. So we can say that. And remember this little 11 symbol right here, that symbol right there, stands for parallel. So this little symbol right here stands for parallel. So we know that AB is parallel to DC. Now we said both pairs of opposite sides need to be parallel. So what's another pair? I'll do blue. So another pair would be side AD and I've lost my cursor. Let me find my cursor. There it is. So the opposite sides over here would be side AD and side BC. And then we're going to show that these two are parallel, but to differentiate from AB and DC, instead of using one arrow, we're going to use double arrows. So this indicates that AD is parallel to BC. So we can say that AD is parallel to BC as well. Okay, great. So that's the definition of a parallelogram, but this chapter is called Properties of Parallelograms. So there are many more properties that we're going to learn. So we're going to go to the next one. So the first one is this theorem 7-3. And in 7-3, we know that it says the parallelogram opposite sides theorem. So that says if a quadrilateral is a parallelogram, then its opposite sides are congruent. So, and it has these little markings here. So right here it says that QR, so here's QR, right here is equal to PS, because those are opposite sides, so they're not just parallel, they're equal. And again, we use these hatch marks to indicate equality. And then also, we also know that, change of color here. Let's go with red. So we also know that PQ and RS or SR are equal, and again these indicate equality, these hatch marks. So the single hatch marks indicate that those two sides are congruent, and the double hatch marks indicate that those two sides are congruent. So let's just try a couple of problems. Let's say that we knew that PQ was 15. So if PQ is 15, let's mark that over here. I want you to find RS. So if PQ is 15, what is RS going to be? Well, opposite sides are equal, so RS is going to have to be 15. So RS would equal 15 also. Similarly, if QR was 23.2, so if we were given that QR was 23.2, how could I find PS? Well, again, opposite sides are parallel, so if QR is 23.2, that means that PS would also be 23.2. Okay, so I'm just going to give you a minute to get caught up. Okay, so this was mostly drawn for you, so all you had to add in here was these few little lines, so I think that you should be done now. So I'm going to move on. So our next theorem is theorem 7-4, or 7.4, which is the parallelogram opposite angles theorem. So this says if a quadrilateral is a parallelogram, then its opposite angles are congruent. So opposite angles are angles that are across from each other. So let's look at angle Q. So here's angle Q, that's this angle right here. And the angle that's opposite it is, of course, angle S. And this is indicated by the arcs, which, remember, indicate that those two angles are congruent to one another. So I know that angle Q is congruent to angle S. And then if I look over here, I have angle P, and it's got two arcs in it, so that's congruent to angle R over here. So Q and S are congruent. I don't know if I said parallel earlier. I meant to say congruent. Angles are not parallel. Angles are equal. So Q and S are congruent, and P and R are congruent as well. So again, if we wanted to add some, to do a practice problem, then we could say, let's say that the measure of angle P was, P looks like an acute angle, so let's say that it's 63 degrees. How could you find the measure of angle R? Well, opposite angles are equal. So if this is 63, then this has to be 63. So the measure of angle R would be 63. Now let's make this one a little more difficult. It looks like angle Q is obtuse, so we'll give it a bigger angle. So the measure of angle Q, lost my cursor there, whoops, let's fix that. Okay. Okay, so let's say that the measure of angle Q was, let's say, 140. And let's say that the measure of angle S was 2x minus 8. Then we would want to find x. So let's find x. Alright, so here we go. We know that angle Q is 140 degrees. And angle S is 2x minus 8. And I know that those two angles are equal. So what do you think I'm going to do to solve that? So I'm going to give you a second to think about that. Alright, so some of you said we're going to set them equal, and that's exactly what we're going to do. Angle Q and angle S are opposite angles, and as such, they are equal to one another. So I can just say 140 is equal to 2x minus 8. And to solve this, I would add 8 to both sides. And I get that 2x is equal to 148. And then I would divide by 2. And I would get that x is whatever 148 divided by 2 is. So let me check that out on the calculator. Gotta turn the calculator on first. So 148 divided by 2. And sure, we get x is 74. So x is 74. So there we did one with a little bit of algebra. Okay, so we've learned now that opposite sides are parallel, opposite sides are equal, and opposite angles are equal. So let's see what's next. So I'm going to give you a second to get caught up. Okay. So in theorem 7.5 we have the consecutive angles theorem. Now we learned about consecutive angles when we learned about special angle pairs. Remember, we learned about alternate interior angles and same side interior angles and alternate exterior and so and so. So one of those was consecutive interiors, but the consecutive interior angles had a different name. They were also what we considered same side interior angles. So let's put same side interior angles down here in parentheses. So we had a theorem about those same side interior angles. And that theorem was if the lines were parallel, then the angles were supplementary. And again, remember, supplementary means adds up to 180. Okay, so consecutive means next to or same side interior. So if you look at this, angle Q or angle X, so these two angles right here, so this angle here, and this angle here, are next to each other. So we know opposite angles are across from each other, and same side or consecutive angles are next to each other. And we learned that opposite angles were equal, but consecutive angles add up to 180. So that gives me x plus y equals 180. So again, let's say that this is, I don't know, 126. So we're given that the measure of angle Q is 126. So the measure of angle Q is 126 degrees. Great. We have to find all the other angles. Okay, so angle S is opposite, so, and they're both x, so obviously they're equal, so S is going to be 126. So the measure of angle S will also be 126. Nope, how did I get way up there? Sorry. The measure of angle S would also be 126. Now Q and P. Well, Q and P are adjacent or consecutive angles, so angles that are next to each other. So those add up to 180. So if I did 180 minus 126, so 180 minus 126 is 54. So I know that angle P is 54. Now Q and P are adjacent, but so are Q and R. So Q and P are adjacent. Let's write that. Q and P are adjacent. But so are Q and R. So I could find R the same way. Again, it would be 180 minus 126. But don't forget that P and R are opposite. So these two angles right here, this angle here and this angle here, are opposite each other. So those two angles would also be equal. So that means that angle R, so the measure of angle R would also be 54. Okay, so I'm going to give you a second. It's getting a little warm. I had to put the air on. Okay. So I think that's good. Now let's go to the next theorem. So let's recap. We have learned that opposite sides are parallel, opposite sides are equal, opposite angles are equal, and consecutive angles are supplementary, which again means they add up to 180. So the next slide is called the parallelogram diagonals theorem, and this gives me some information about the diagonals. So again, it says if a quadrilateral is a parallelogram, then its diagonals bisect each other. So let's talk about what that word bisects means again. So we've talked about it a few times, but one more time. What does bisect mean? Bisect means cuts into two equal pieces. So what that's saying is that I have this whole line here, QS, and this whole line here, PR, these are diagonals, and they cut each other into two equal pieces. So that means QS got broken into two equal pieces, namely QM and SM, and PR got broken into two equal pieces, and those two equal pieces are PM and RM. So again, that leads us to some problems that we could do. If we said that QM was 5, so that would indicate that this segment right here is 5. I've lost my cursor. Oh, there we are. 5. And then what would MS be? Well, MS would be 5 also, because these pieces are equal. Alright, and then we're also, if we were given that this was 8, if PM was 8, then of course MR would also be 8. Okay. So now we know that the diagonals of a parallelogram bisect one another, which means they cut each other into two equal pieces. Okay, so we're going to get ready to do some practice ones, but let's just recap what we've learned. We've learned that opposite sides are parallel, opposite sides are equal, opposite angles are equal, and consecutive angles add up to 180 degrees. And the diagonals cut each other into two equal pieces. Okay, great. So let's try some practice problems. So these are in your book. Some of them are easier than others, but we'll get through them. So here we go. So this first one. Well, are these sides or are they angles? Yeah, they're they're sides, right? So the thing is, I could say that 4x is equal to y, but that would lead me to a problem because I'd have two letters in the same problem, right? So I could say, don't do this, but I could say that 4x is equal to y. The problem is I can't really solve that because I have two different variables, right? So before we start trying to do systems of equations, which might be possible, we should see if we have a pair of sides that have the same variable, and we do right here, these two sides. So x plus 18 and 3x minus 2 are opposite sides. Excuse me. And again, we know that opposite sides are equal. So I can say x plus 18 is equal to 3x minus 2. And the good news about this is I know these are both x's, so I can solve a problem like that. So it looks like the best thing we're going to do here is subtract x from both sides. And I get 18 is equal to 2x minus 2. Okay, so that's pretty good. 18 is equal to 2x minus 2. Now I'm going to add 2 to both sides. Those go away, and I get 2x is equal to 20. Alright, so now I know that 2x is equal to 20, so how am I going to solve that? Well, I'm going to divide both sides by 2. So I'm going to divide by 2, and I get that x is, the 2's cancel, and I get x is 10. Now it says find the value of each variable. So one variable is x equals 10, but again there was another variable. So we're going to have to do a little substitution here. So let's do this in another color. So let's pick another color, like, ooh, how about this purple? Let's see what that looks like. So x is 10, and right there, x is 10. And I'm going to plug that in there for x. So I get 4 times x, but remember x is just 10. So now I know that this side is equal to 40. So this side right here is 40 units. So that means that y is also 40 units because these two sides are opposite. So y is also 40. So I got that x was 10 and y was 40. So I'm going to give you a second. All right. Good enough. Next problem. So problem number 2, we have a pair of sides and we have a pair of angles. Okay, so again we need just one variable. So if I look at these sides, I get 4x minus 3 would equal y over 5. And again, that's a problem because I have both an x and a y. So we're not going to go that route. We're going to look at these two angles first and see what that gives us. Well, this says 4x minus 37. And again, this angle right here is opposite this angle here, opposite angle 49. So we learned that angles that are opposite from each other are equal. So I can say that, let me get a pen, switch the color, I kind of like the red, so I'm going to go back to the red. I can say that 4x minus 37, 4x minus 37 is equal to 49. Okay, great. So to solve this, I'm going to add 37 to both sides. And of course these cancel, and I get 4x equals, well, what's 49 plus 37? Well, this would be 50 and 36, so I think 96, but we could also do it this way. 9 plus 7 is 16, and then I carry the 1, and I get 5 plus 3 is 8. Or sorry, 5 plus 3 is 8, so 86. So 49 plus 37, just going to double check that. Yep, it's 86. And then, of course, I have to figure out what x is. So to find x here, I'm going to divide by 4. So 86 divided by 4. Use a calculator for that. And I got 21.5. So I could reduce or I could divide. I guess I'm going to go with the decimal. So the decimal again was 21.5. Oops, sorry. So x is 21.5. Well, now that's good, but now we have to find y. So we're going to have to plug in. So I'm going to take this, again I'll get a new color, we'll go back to that purple color. I think I might erase this. Okay, so we'll go with the purple. If I take this 21.5 and I plug it in here for x, right? Then I would get 4 times 21.5 minus 3. And 4 times 21.5 is 86. So I get 86, take away 3. And 86 minus 3 is 83. So I know that this side right here is 83 units. Okay, so now I want to find y over 5. So I know that these two sides are equal. Can't find my cursor. And there we go. So these two sides right here are equal to one another. So I know that 83 is equal to y over 5 because opposite sides are, again, equal to one another. So I can write that down. 83 is equal to y over 5. Now to solve this, I'm just going to put this over 1 and cross multiply. So I get 1 times y, which is y, and then 5 times 83. And 5 times 83 is 415. So I get y is 415 degrees. There we go. So y is 415 degrees. Not degrees though. Sorry. 415 flat, just 415 units. So let's get rid of the degrees. So y is 415. So we found that x was 21.5 and y was 415. So I'm going to give you a second. To get caught up. I just realized I didn't finish my X, so whoops. So there, 83 times 5. Okay, great. Moving on. Okay, now this looks like a pair of diagonals. And remember, the theorem said that the diagonals of a parallelogram bisect each other. So that means that these pieces are equal. So let's get a pen. So this piece right here, 5y minus 16, is equal to this piece right here, 3y. And look at that, the good news is these are both y, so I can just go ahead and solve these. So these two pieces are equal. So I'm going to say that 5y minus 16 5y minus 16 is equal to the other piece over there, which was 3y. So, I don't know, I guess I could subtract 3y and add 16, or maybe I'll just subtract 5y. So I'm going to subtract 5y, and I'm going to be left with negative 16 equals negative 2y. So I can divide both sides by negative 2. And I get y is 8. So now I know that y is 8. Okay, so x. So let's switch colors. Oops, I forgot to pick a different color. I don't know, let's try green for something different. Okay, so this time we have 2x plus 10. So that's this line right here. Whoa, kind of going off there. But that line's 2x plus 10, and this line's 4x minus 2, and we know that these two pieces are equal to each other. So to solve that, I'm going to say 2x plus 10 is equal to 4x minus 2. And then I would subtract 2x from both sides. And I get 10 is equal to 2x minus 2, because 4x minus 2x is 2x. And I'm going to add 2. And it looks like I get 2x is equal to 12. And then dividing by 2, I'm going to get that x is 6. So I got y is equal to 8 and x is equal to 6. And I'll give you a second. And then we just have the rest of the problems, which should actually go pretty fast. There's no algebra involved in these next ones. Okay, let's go to the next slide. So here we go. Next slide. So here we have a new parallelogram. That's MNOP, and we have some measures. And again, all of you should have this in your books, so you don't need to copy it, but maybe I'll give you a minute or 30 seconds or so for those of you that didn't bring it to go ahead and draw it really quick. And while they're drawing, let's look at this. It looks like we're looking for side measures. It says side PO. Remember, PO without anything over the top of it means the length of PO. So let's maybe remind ourselves of that. I'll write it up here. So remember, PO with a line over it means segment PO. But PO with nothing over the top of it means the length of PO, or the distance from P to O. Okay, so good. So here's PO. PO is this line down here. So there's PO. So PO is a side, so we know that opposite sides are equal. So what side is opposite PO? And right up here it's MN. And the good news is we know that M and N, we already know how long side MN is. So MN is 24. So that means that PO is also going to be 24. So PO is 24. Okay, great. Let's switch colors. Maybe I'll do this light blue there. Okay, next on our agenda is OQ. So here's OQ. You can see it pretty good. There's OQ. Okay, and OQ is part of a diagonal, and I know that the diagonals bisect one another. So OQ is going to equal this part of the diagonal. So that means OQ is going to equal MQ, and MQ is 14, so that means that OQ is 14. And let's not forget that we found that PO earlier was 24. So now I know that OQ is 14. So OQ is 14. All right, now let's try another color. Let's go with the purple one. All right, and purple is NO. All right, so here's NO. NO is this segment right here. So there's NO. And N, remember, opposite sides are equal, so NO would be equal to this side over here, MP. Whatever that side is. Oh, I forgot to mark those other ones equal. So these are equal. We'll do 3's. And these two are equal too. So maybe we'll do 2's for these. Okay, so if MP is 26, then that means that NO must also be 26. So that has to be 26 too. So NO is 26. And then it looks like we just have one more segment to find. And then all the angles are on the next screen or slide. So let's go with red now. Okay, so the only thing left to find here is PQ. So here's PQ. and that's congruent to QR. Now we've already used 1, and we've used 2, and we've used 3, so we're going to do Roman numerals here. This is 4. IV is 4. Okay, so I know that PQ is congruent to QN, and we know that QN was 20.7, so that means that PQ must also be 20.7. So 20.7. Okay, so let me just give you a minute to get yourselves caught up. I'm going to test out another color while we're trying that. What about that orange color? There we go, orange. That's not very orange. It's kind of a brownish. What other colors do we got? Yeah, really, I don't know, not too much. Okay, we'll go on to the next slide then. So we found sides here. So pretty easy, opposite sides were equal. So 24 and PO, and then MP was 26, so that meant that NO was 26, and then we have part of a diagonal, MQ, and that's equal to this part of the diagonal, QO. And then this diagonal, PQ, is equal to this diagonal, QN. Okay, so here we have some angles. So I have a nice fresh picture. Unfortunately, you do not. So maybe you could do some erasing or something. All right, so for these angles, they gave us a 3-letter name. So let's just review 3-letter names. So the important letter always is the middle letter. So in this case, that would be M. Oh, I have that awful color. I didn't change it. Pink color. Let's go to red. So that middle letter is M. So that's where my arc is. And it says to start at P, go to M, and then N. So I'm going to maybe highlight this. I wonder if I'll be able to see the highlight at all. Yep, I can. So here is PMN. So that's this angle right here. So that angle right there. Okay. Okay, so we have to find that big angle M right there. And let's switch back to not a highlighter, but a pen. And we'll go with red. So PMN is going to equal this angle right here. The problem is we only know this little part of that angle right here. So I only know that little part of the angle. So, and these are not necessarily equal. That is true if this was a different shape, but for parallelograms, any regular parallelogram, these two angles are not necessarily equal to one another, and they're certainly not in this case. Okay, but the good news is up here, we're given this big angle here. So this big angle right here is 68. And this angle, N, and this angle, M, are consecutive angles. And remember, consecutive angles add up to 180 degrees. So if I say 180 minus 68, I'm going to get 112. So I know that this angle right here, angle M, is 112 degrees. Okay, great. So another pen, color. We'll go with the purple. We're looking for NOP. And NOP is this big angle right here. So maybe ooh, I don't know how that happened. Let's see if I can go back. There we go. I think I'm gonna use the pen, not the highlighter. And we had the purple pen. Okay. So NOP, the important letter, remember again, is O. So that's the middle one. So we're gonna start at N and go down to O, whoa, and over to P. So NOP is this big angle right here. And that angle is equal to this big angle M that we just found, and those two angles, that's 112, so that makes this one 112 as well. So NOP is 112. And then we have angle OPM. And OPM is this angle right here. I'm going to do this one maybe in green. So again, the important letter there is P. So P. So we're going to start at O and go all the way over to P and up to M. So that's this big angle here. And the good news is this angle is opposite with this big angle N right here. So if that's 68, then that makes this 68 as well. So OPM is 68 degrees also. And then this got cut off a little, so let's rewrite what this says. This says NMO. So number 11, we'll do this maybe in that light blue. So this says find the measure of angle NMO. Didn't realize when I created it that it was that close to the bottom. But right there's angle M. So that's the important one. But this time it starts at N. So here's N. And it goes to M. And then all the way down to O. So we're just looking for this part of the angle right here. Okay, well you may notice that this angle right here is alternate interior with this angle down here, and we have a theorem that says when the lines are parallel that alternate interior angles are equal. So you see how this angle right here is in between these two lines, and this is between, this angle right here is also between these two lines, and they are opposite sides of this line, so they're alternate interior, and when the lines are equal, then the angles are equal. So that tells us that this little angle in here, that little angle just right there, is 59 degrees. So this is 59 degrees. Yikes. Having all kinds of cursor troubles. There we go, 59 degrees. Alright, great. So, we are done. Okay. So be good for the sub and do your homework.